Good afternoon, ladies and gentlemen. Mr. Rowan here. If you recall, last class we talked about some angle relationships that we see when we have two parallel lines and a transversal that goes through them. So today we're going to determine whether lines are parallel given information about the angles. So we're kind of going backwards. Um, so just to take a look at this, to review, if A is parallel to B, then angle 1 and angle 2 would be what kind of angles? So first of all, we would say that they're congruent to each other. Angle 1 and angle 2, they have the same measure. So we'll write that they are congruent. And they also have a particular name. They're called corresponding angles. Corresponding angles. Now, so we're getting into a little bit of our logic. So when we do the converse, we change the order, if you recall. So now you see it's reversed. If angle 1 is congruent to angle 2, then A is parallel to B. So if two lines are cut by a transversal so that corresponding angles are congruent, then those lines are parallel. I think I mentioned last time that, or not last time, but earlier in the unit, that when you have a statement and a converse being true, you find that the biconditional is true as well. Okay, so let's check this. If two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. That's true. And again, that way, that works backwards and forwards too. If they're parallel, then the alternate interior angles are congruent as well. So like we see, 3 is congruent to 4. And let's go down to this one here just a little bit further down. If two lines are cut by a transversal so that alternate exterior angles are congruent, then those lines are parallel. So this should make perfect sense. We're just basically taking exactly what we learned in the first video and we're doing it slightly backwards. So, and then next you can probably guess what the last one will be. But if two lines are cut by a transversal, hang on, let me just write this example. All right, so 5 and 6. So if two lines are cut by a transversal so that our consecutive interior angles are supplementary, or we'll write same side interior. You can say either way you like, same side or consecutive. Then those lines are parallel. Okay. Let's go down a little bit. Okay. And just to show you an example, we'll see to remind ourselves what same side interior angles look like. They would look like these. Boop. We'll call this 7 and 8. Perfect. Now the other way that you can think about this is same side exterior angles. If those are supplementary, then the lines are parallel as well. Again, I think I mentioned that we don't really hear same side exterior as an angle measure that we typically talk about. I think it's not one that you'll see on the SOL, but just for your own enrichment, we'll go over that and take a look at what same side exterior angles look like. So those would be 9 and 10. And those are supplementary as well. You should be able to tell that they're not congruent because when the line is slanted like this, it's very obvious that 9 is acute and 10 is obtuse. So we should be able to tell that they're supplementary rather than congruent. So there's two angle relationships that don't prove that lines are parallel. The first one is vertical angles, and the other one is linear pairs. So the main reason that this doesn't work is because you have to have angles that touch two different lines. So if you'll see in some of the examples that we do in a little bit why that doesn't quite work for vertical angles and linear pairs. The thing is that vertical angles and linear pairs are always congruent or supplementary, and it doesn't matter whether or not the lines are parallel. So let's take a look here. What value of x will make r parallel to s? So we need these angles to be either congruent or supplementary. So let's figure out what it should be. Well, they're both inside the lines, and they're on different sides of the transversal. So that means that they are alternate interior angles. And if you look back at your notes, you know that alternate interior angles are congruent. So we would write it just like this. 3x equals 2x plus 20. They're the same. So we'll put them on opposite sides of the equal sign. And then we'll just quickly solve for x, and we get x equals 20. Splendid. Okay, now let's move down here just a little bit. Can we prove that each pair of lines is parallel? So let's start with number one. We have 65 here and 65. So what kind of angles are we looking at? Well, if we just check out their relative positions, the one on the top is 65. It's on the bottom left. And the other 65 is also on the bottom left. So we have our yes or no. So we have to first figure out what kind of relationships they are. And we see that yes, they are, and that is because they are corresponding angles. And when our corresponding angles are congruent, our lines have to be parallel. Let's check out 2. So we have an angle on the top left and an angle on the bottom right. So they're not corresponding, but they are both exterior angles, and they're on opposite sides of the transversal. So we could say, yes, they are. And that's because we are looking at alternate exterior angles. Scroll down just a little bit. Do a couple more examples. 125 and 95. Obviously not drawn to scale. Now it looks like the lines are parallel, but what kind of angle relationship would this be? Well, we have two angles that are both inside the lines here, and they're on opposite sides of the transversal. So these would be an example of alternate interior angles. Now, if our lines are parallel to each other, these alternate interior angles should be congruent. And since they're not, we know that the lines aren't parallel. Okay, now 4. So this is an example of what I just talked to you about at the bottom of the first page. Knowing that two angles are vertical doesn't help us at all because we don't know anything about the line on the right. Now, they may be parallel, but we can't prove it giving this information. We can't disprove it like we could with number 3, but we just don't have enough information because we don't know anything about the angles between the line on the right and the transversal. Okay, so let's take a look at number 6. You can try 5 on your own, see if you can figure it out. But let's look at number 6. So we have 60 and 120. So these would be consecutive interior angles, or same side. Now, what do we know about consecutive interior angles? Well, they're not supposed to be congruent, but they are supposed to be supplementary. So let's see. 60 plus 120, does that equal to 180? Get out your calculators or your fingers. Last time I checked, 60 plus 120 does equal to 180. So those lines are parallel. Okay, those are supplementary. Running out of space, supplem. All right, let's take a look at 50 and 130. Now this one is a little bit tricky because we don't have an exact relationship, but we know that our vertical angles are congruent. So if we have 50 on the top left, then we have to have 50 on the bottom right, just in terms of that top circle up here. See, just in terms of where this transversal hits this line. So it turns out that, yes, they are, because what we get is 130 and 50 as same side interior angles that are supplementary. Okay? So 50 plus 130 does equal to 180. So let's take a look at these. All right, 110 and 70. Well, those are supplementary angles, and it's a linear pair, but we don't know anything about what happens on the top. Okay, so a linear pair is not enough information. Now, they may be parallel, but we really don't know. Okay, so that is all the information that I have for you today. So enjoy your video. Thanks for watching. I will catch up with you in class. Have a good day.